Welcome to the MTD Technical Corner. Today we're going to be technically reviewing multi-sensor technology from LK Metrology on the SCANTEK 5. Steve, welcome to the MTD studio. I'm really looking forward to find out about this new innovation and solution from LK.
Brilliant, and thanks again, Gio. It's good to be here and to obviously present this technology to you. So,
absolute pleasure.
Yeah, so basically, for those that don't know LK Metrology, we've been around since 1963. We were the pioneers of the bridge type CMM. But in addition to that, we've also worked very closely with Renishaw, so they've always been a very strong collaborator and a strategic partner for us. So obviously they're the market leaders in probing technology, and we're leading the way when it comes to ceramic bridge technology on CMMs. And in all fairness, lots of people may have already heard of the Revo 5. It's been around now for probably about a decade, but Renishaw are constantly innovating and bringing out new sensor technology to complement the Revo 5. And then to complement that too, we've got the SCANTEK 5 CMM, which basically is designed specifically for the Revo. And now the good thing is that Renishaw, as I say, they've just recently launched a new probe, which I want to talk about.
And the new probe, we'll be moving on to that shortly. But
yeah.
In regards to the SCANTEK 5, we see it changing to different heads, and it's also capable of surface finishing. Can you just give us an indication first of how flexible and modular it is, and what different applications this solution can lend itself to? And also, Steve, it's also automating from one head to another, isn't it?
Yeah, it is. Yeah, no. So basically, the benefit of Revo is all about speed, because early days, maybe people only ever used a touch trigger probe. So effectively, you would take a single point and it would just retract and take another bond. And okay, it did a very good job at that. But obviously, you know, in today's pressurized times with production processes, and you know, time is money. So the last thing you want is your inspection process to be the bottleneck. So with the Revo, what you find is that you've got, you know, up to 4,000 points per second contact. So if you're measuring a big bore, rather than just taking single points, it will spin around and go in and out very quickly, and you've got thousands of points, all with the same sort of accuracy that you're used to. So the other benefit of Revo is, as you can see on here, is that we've got different sensor technology. So this particular probe is actually taking surface finish. So in the past, what you'd have is you'd have multiple stages of inspection. So you may have dimensional control, then it would come off the CMM, and then it would go onto another machine to actually look at the surface finish. So the beauty here is that you're doing it all in the one operation. So that then is all fully automated. It gets machined, and then it goes to the inspection process, but the inspection process completes 100%.
So it's staying on one platform to inspect the part completely.
Absolutely.
And it hasn't stopped there now, Steve. Now we're moving on to this new technology, the Ultrasonic Probe. I've never heard of this before today. So please give us a technical review on this Ultrasonic Probe and explain how this works and what it does.
Well, it's quite clever, really. When you think of it, ultrasonics is out there, and people may refer to it as when a woman's been scanned when she's pregnant, looking at the baby, so that's using ultrasound. And the difference there is that you generally have to put a gel on the surface, and obviously the machine is taking the ultrasound waves and it's trying to build a 3D image. Now the beauty here is that we've got the 3D accuracy from the CMM, so we're only really looking at a distance. And without putting gel on the surface, we actually have the gel inside the tip. So the tip is actually like a tablet that you'd swallow, you know, so it's actually got the gel inside. But the beauty there is that it's clean, it's simple, it's effective, and we can measure up to a 20mm thickness to an accuracy around about 10 microns. So it's not for everything, but you can imagine, let's say this blade here that we're measuring, this actually could be a hollow structure. It might be 3D printed, so there may be some voids in there, and what is key is that we actually need to know what the thickness of that wall is, because obviously if it's too undersized, then it could fail in operation.
So I would assume, Steve, that there'd be no other way of checking certain features without this.
Yes and no. I mean, obviously, this traditionally may have been done on CT scanning, which again is a very clever technology, but CT tends to be very expensive and quite time consuming as well. Whereas you can see here, we're literally taking points very quickly, and this is just emphasising, if we move around, we can see what sort of error map we're getting, but it's sub 10 micron, so it's very quick.
So it's checking depths and depths that you wouldn't otherwise be able to check on a CMM. give us some examples of applications and components.
Yeah, exactly. So, I mean, when you think about aerospace, you can imagine, let's say we're looking at the undercarriage and you've got these big shafts, so, you know, maybe made out of stainless steel. You know, they might be 1.2, 1.5 meters long, but they're hollow. So in the past, you'd have a probe that would go inside to measure diameters, and then you'd take it out and you'd measure the outside of it, and then you'd do the comparison to work out what the thickness is around there. Now, the challenge there is that you need a very long machine to get inside, and of course the cost of the probing is quite prohibitive sometimes, and it could also be quite slow as well. So here you can use it with the Revo, you can quickly whiz around and get those thicknesses very quickly. And again, here's another application here too. So I mean, you've got a machine part here, but let's imagine this is a wing skin, you know, so it could be a very large part, and it may have pockets underneath. So when it's in one orientation, you can see here that we've got some pockets. But let's say it's got pockets underneath and it's sitting on a table, then how do I measure underneath without having to keep flipping the part over? So the beauty here is with the ultrasound probe, you can go in and take those thickness measurements very quickly, because again, thickness is really crucial for aerospace components.
Steve, I've never seen technology before like this within our industry. How should people get in touch to find out more?
Well, I think basically we're a well-known company, so obviously visit our website, do a contact inquiry, and then we'll obviously invite you up and you can have a demonstration on site.
Steve, it's been an absolute pleasure. I can certainly see the benefits of this technology, saving operations as well, Steve,
Absolutely.
potentially. If you want to find out more about this new technology, contact LK Metrology. Thanks, Steve.
Thank you, Gio. It's a pleasure.